This video is going to work through the review exercises for the midterm, questions 22 to 31. This is covering material in Chapter 4 about bivariate distributions of discrete random variables. So we've got x and y are two discrete random variables with a joint probability mass function given below. Notice that I am only given a sort of variable here, c, for the probability that x equals 0 and y equals 1. And so I need to first of all figure out what that is. Now, the way that I do that is to remember that all of the probabilities in the joint probability mass function need to add to 1. So if I add up all these probabilities, I get 16/20, which means that c has to be 4/20 in order for the probabilities to sum to 1. So c is equal to 4/20 is the first thing I need to figure out. So question 22, c is equal to 4/20, and as I said, I just added up all of these other probabilities and figured out what must this be to make them sum to 1. For 23, I'm finding the marginal distribution for x. So to do that, what I'm going to do is I'm going to say, okay, for each of the values of x here, I have -2, 0, and 2. I'm going to sum the probability that the joint probability that x is equal to -2 and y is equal to all the different possible values of y. So I'm just adding across. So I've got 1/20 plus 2/20 plus 1/20 gives me 4/20. If I add across with x equal to 0, I get 4/20 plus 2/20 plus 1/20 is 7/20. And then here I have 4, 5, 6, 7, 8, 9/20. And then I just again need to make sure that these add up. So let's see, 4 and 7 is 11 and 9 is 20, so that's perfect. So here's my x and my marginal distribution of x is there in the margin. No, scooched off a little bit. There we go. So if I wanted to write that out separately, I'd write, okay, I've got x and the marginal distribution of x, -2, 0, and 2, 4 out of 20, 7 out of 20, 9 out of 20. There we go. So there's our marginal distribution. The marginal distribution of y, I'm going to similarly work. I'm going to instead be adding down across all the different values of x here to find the total probability that y is equal to 0. Here I've got 1/20 plus 1/20 is 2/20. Here I've got 2, 4, that's 6, 8/20. It's the probability that y equals 1. The probability that y equals 2, I've got 4, 6, 7/20. And the probability that y equals 3, I have 1 plus 2 is 3/20. Again, I always check to make sure that my probabilities sum to 1. 8 and 7 is 15, and 3 is 18, and 2 is 20. Yep, that sums to 1. So my marginal distribution for y again, my values are possible 0, 1, 2, and 3. And my probability that y is equal to 0 is 2/20. For 1, it's 8/20. For 2, 7/20. And for 3, 3/20. There we go. So there's my marginal distribution. Okay, 25 asks me to find the conditional distribution of x if y equals 2. So let's see. So I'm finding the conditional distribution of x if y is 2, so that's going to be, just using the notation of the book, I'm looking for g of x given that y is equal to 2. So the way that I do this is for each value of x, I'm going to take the joint probability of x being equal to that value little x and y being equal to 2 and divide it by the probability that y is equal to 2. So it's going to be, and I know the probability that y equals 2 is 7/20. So I'll start through my different values of x. When x is -2, the probability that x is -2 and y is equal to 2 is 1/20. So g of -2 given y equals 2 is equal to 1/7. When x is equal to 0, okay, when 0 and y equal 2, I have 2/20 over 7/20. It's 2/7. And for x equals 2, I have 4/20 is the probability that x is equal to 2 and y is equal to 2. So it's 4/20 out of 7/20. So my g of 2, given that y is equal to 2, is 4/7. And then because this is still a probability distribution, I need to make sure that these sum to 1, and they do. Okay, let's see. Now I'm looking for the conditional distribution of y if x is equal to -2. Let's see. So we call this h of y given x. It's going to be the probability that x is equal to x and y is equal to y, divided by the marginal probability that x is equal to the value x. There we go. We just had the test of the National Alert System in the middle of our video. I guess it worked. All right, sorry about that. Okay, so as I was saying, to find the marginal distribution of y given x, we take the joint probability that x is equal to x and y is equal to y, divided by the marginal probability that x is equal to x. In the situation with x is equal to -2, we're going to be looking for the joint probability of -2 and y, divided by the marginal probability that x is equal to -2, which we have up here is 4/20. Okay, so for all of our different values of y, so we'll look at y, and we'll look at h of y given x is equal to -2. So let's see, y could take the value 0. The probability that y is equal to 0 and x is -2 is 1/20. 1/20 over 4/20 gives me 1/4. Y could be equal to 1. The probability that y is equal to 1 and x is equal to -2 is 2/20 divided by the 4/20 gives me 2/4 or 1/2. Probability that x is equal to -2 and y is equal to 2 is 1/20 divided by the 4/20 is the marginal probability that x is equal to -2 gives me 1/4. And then finally y can take the value 3, but notice that when x is equal to -2, the probability that y is equal to 3 is 0, so that conditional probability is 0. And again, we need to sum and make sure these equal 1, and they do. So there's our conditional distribution of y given that x is equal to -2. Alright, so now I want to find the mean of x. Okay, so the mean of x. The easiest way to find the mean of x is to use the marginal distribution of x. So, here's my marginal distribution of x. Let's see which question number I'm on. It is the mean of x, 27. Okay, so 27, I'm going to find the mean of x. What I'm going to do is I'm going to take all the possible values of x, and I'm going to multiply x times the marginal probability that x takes on that value. So that's going to be negative 2 times 4/20 plus 0 times 7/20 plus 2 times 9/20. This gives me minus 8/20 plus 18/20, which gives me 10/20 or 1/2. If y is equal to 2, what is the expected value of x? So I'm conditioning on y equal to 2, so I want to use my conditional value distribution of x given that y is equal to 2. So I'm going to be working with this distribution, and I want to find the mean of x given that y is equal to 2. So to do that, I'll work right here. So this is 28. The mean of x given that y is equal to 2. To do that, I'm going to take, for all the possible values of x, I'm going to take x times g of x given that y is equal to 2. So it's going to be negative 2 times 1/7 plus 0 times 2/7 plus 2 times 4/7 gives me minus 2/7 plus 8/7, which is equal to 5/7. So there's my answer for 28. Question 29 is, what is the probability that x is equal to negative 2? It asks what kind of distribution we use, joint, marginal, or conditional. So since I'm interested only in the value of x, and I'm not talking at all about y at all, I'd be using the marginal distribution to answer that question. So the marginal distribution of x tells me that the probability that x is equal to negative 2 is 4/20. So let's see, 29, I use the marginal distribution of x, f sub x of negative 2 is 4/20. For question 30, what is the probability that x is equal to negative 2 and y is equal to 2? Which distribution would you use? So here, because I'm looking to see the probability of an intersection, I use the joint probability. So for 30, I use the joint PMF. I'm looking for f of negative 2, 2. And if I come up and look at my table, negative 2, 2 gives me 1/20. And then finally, for question 31, if x is equal to negative 2, what is the probability that y is equal to 2? Here I'm interested in both variables, but I've got an if statement, so that's conditional on x being equal to negative 2. Right? So I'm going to be using a conditional distribution of y given x equals negative 2. So once again, I have that distribution here somewhere. Here it is. Right. What I'm looking for here is I'm looking for h of 2 given x is equal to negative 2. Right? This is for 31. So I'm using this conditional distribution. Am I on the page? Just barely. And from this distribution, you say, okay, if x is equal to -2, the probability that y is equal to 2 is 1/4. So that's how we're deciding which distribution to work with. If we have an if statement, we're going to be using a conditional distribution. If we have a statement that involves only one of the variables, we're focusing on the marginal distribution. And if we have an and type statement here, where we're thinking about an intersection, that's what we get from the joint distribution. Thanks.